welcome to my channel, STEM Cafe, where you make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, and enjoying. Today we are handling centroid. The concept of centroid is to show a place in an object where the whole force can act and it represents all the other forces. Summation of all the other forces can act true and it will be balanced. How do I mean? You can see this plate I'm holding. The force is actually through the center, the total force. But if this thing is cut now, the center will shift. If it is cut now, the center will shift. And it is a very simple concept. But when the shape is not regular like this, it requires some kind of analysis to get the centroid. Let me explain using moments. Most of the time, when we have an object that has, that has magnitude, that its weight is of good magnitude, we refer to that centroid as the center of gravity of the object. Assuming we have an object like this, all these ones have some kind of weight as they are scattered. So if I should handle it here, it will not balance. The other side will cause the imbalance. But if I bring my hand at the center here, it will balance, which means that this point here, this point here, this point here, this point here, the moment about this point I refer to as center is equal to 0. Let's show true simple analysis here. Let's say this is a meter rule of 100 centimeters. Okay, let me use 100 meters. It is no longer a meter rule. Let's say we have an object of length 100 meters. And we have a weight here. This is 10 meters. This is 10 Newton. Another one at this place. Let's say this is 30 Newton. And this is 30 meters. Another one here. Let's say this is 60 meters. Let's say this is 40 Newton. That's 8. Okay. Let me now put 20 Newton here. Now, if I want to find the center, we have, let me see, 100 Newton can act true. And the moment will still be equal to the moment of this. How do I get it? The sum of the weight is 100 Newton. I want to now look for a point where this 100 Newton will pass through. And the moment will still be equal to the moment this one is producing. So let's look at it from here. Let's say AB. Total moment about A. Total moment about A is equal to 10 times 10 plus 30 times 30 plus 40 times 60 plus 20 times 100 Newton meter. So what does that give us? It gives 100 plus 900 here plus 900 plus 2,400 plus 2,000. So this is 4,400, 4,500, 5,400, 5,400 Newton. Look and correct. Now, the total moment is 5,400 Newton meter. Now let us look at the points where this 100 Newton, the total weight, will pass through, and will give us this 5,400 Newton meter. That will be, let's call it G. So G, so it is 100 times G will be equal to 5,400 Newton meter. So G will be equal to 5,400 over 100, which is 54 meters from the point A. 54 meters from the point A. Now, the interesting part I want to show you. Please. So you can see, which means that if this 100 Newton passes through G, which is 54 meters from the point A, it's going to give us equal moments as these four forces. We have gotten that. Now, let us now take the moments of all these four forces about this point G, and let's see what it will give us. So about this point G, let's take total moment about G. The clockwise moment will be negative and the anti-clockwise moment will be positive. So we are going to have 10 into 54 minus 10 plus 30 into 54 minus 30. This is clockwise. Minus 40 into 60 minus 54. Minus 20 into 100 minus 54. So you can get it like that. Let's quickly do it. So you can see, after doing the whole calculation, the moment about the G is 0. So that is what we talk about centroid. It is the point where the moment of all the other forces around, of all the areas, of all the volumes around, will be equal to 0. And it's the point where you can balance that shape without fear, and it's balanced, just like I did here. That is the centroid. So for different shapes, we need the knowledge of integration to be able to analyze and find the centroid. There are the other techniques, but integration helps us out a lot in this situation. Now, if we want to find the moment of this, the centroid of this shape, we have seen that y equals to fx. And this point is y, and this place is x. The thickness is delta x. You understand? So, if I want to find, just like we did the other time, all these, small shapes have their own moments about this place. To be able to find the centroid, what do? I must be able to find the total weight or area or volume of this shape. And after doing that, I will now take in cognizance the moments of all these small, laminar shape from this place. Add it together and then divide it by the mass, by the weight, by the volume, by the area, whatever. So we talk about area if it is flat plate and it has even thickness. You understand? It has even thickness, even density or whatever. So let's look at it like that. Let's say that, like this one now, it has density, uniform density per unit area. That is, it's flat. Now, the area of this place, area will be equal to y delta x. So total area from our knowledge of integration, total and from x1 to x2, area will be equal to integration of y dx from x1 to x2. So we have gotten the total area. Now let's look at what the moment of this small shape about this place will be. Just like we have done for that one. This place is x, and this place is y, and we have this. So moment of the shape about y axis is equal to x, y, delta x. That's what it will be. Now, because it will vary for all these ones, like this one, let's call this one y1. For this one, it will be x1, y1, dx. For this one, it will be x2, y2, dx, delta x. So it will continue like that. So the total moment now, total moment will be equal to summation x, y, dx from x1 to x2. So you can see, just like you are finding the moment of each of them, just as I did for that beam initially. So that is the expression for the moment. So for centroid now, it will be total moment over total area, which is x, y, dx over summation y dx, x1 to x2, x1 to x2. Simple. That's how to do it. So I don't want to confuse it with other ones we have done before. That's the simple way to go about it. And if you have the shape, regular shapes, we can get it for it. There are standard shapes, and we have used this to get the centroid. Very easy to calculate. Just be confident in applying the formula. That's all. Now we have gotten that of finding the value of centroid, I mean of the distance x from the y-axis. Now, you can see that this is not the center. You cannot find one straight line for the center easily like that. You have to find that of y along this place, the centroid along this place. Now, if you look at it, we will look at the centroid as saying, for this one, for this shape, it will be equal to y. For this shape, sorry, the centroid for this shape is y over 2. Centroid for the street is equal to y over 2. Now, let us now find the moments of this one about this place. Moments of the street about the x-axis is y over 2 times y. So that is the moment. And you can see, for this one we have this. For another one, it will be like that too. For this one too, it will be like that. So you can see, it is varying. It is varying. So, y1, this is y1 over the x. y2, this one is y2 over 2. y1 over 2. So if we add everything together, we are going to have total moment about x is equal to summation y over 2 x. So which is equal to x1 x y squared over 2 x. So centroid is equal to x y squared dx over the area y. So you can see the area is the same in both for both. When you are finding the centroid about x-axis, the centroid about y-axis, the area is the same. But it's only this one that we consider the moment of. It's just like multiplying this by half the distance here, multiplying this by the distance here. Is that clear? So that is all. So let me just give you a summary here. For x, that is the centroid x. It's going to be xy dx over y dx. For y, it will be half y squared dx y dx. So you can see, that is how it is done. Very simple and straightforward. Just be careful when you are taking your street and calculating it. Let's look at one or two examples. Now let's quickly handle this simple one. Find the position of the centroid of the figure bounded by y equals e raised to the power 2x. The x-axis, the y-axis, and the ordinate at x equals to 2. You know how to go about it. You know that our x will be equal to x y dx over y dx. Our y will be equal to half y squared dx over y dx. So let's come to what Robert said y dx is common to the two. So the area is equal to y dx. You have been told from the x-axis, the y-axis, and the ordinate at x equals to 2. So we know that it is from 0 to 2, which is e raised to the power 2x dx from 0 to 2. So that is equal to e raised to the power 2x over 2 from 2 to 0. So we know that will be half e raised to the power 4 minus 1. Now for the total moment about the x-axis, total about x-axis, I'm going to have xy dx from 2 to 0, which is x e raised to the power 2x. And we are going to apply integration by parts. So that will be u dv. So what is my u? U equals to x. My dv is equal to e raised to the power 2x. Okay. So v will be equal to e raised to the power 2x over 2. So I'm going to have something like this. uv, u, that is x, e raised to the power 2x over 2, minus v, e raised to the power 2x over 2. What is my du? My du is dx. This one is from 0 already. So if I should integrate this part again, it's going to give me x e raised to the power 2x over 2 from 2 to 0 minus e raised to the power 4x. E raised to the power 2x over 4. But this is half already. From 2 to 0. So the total moment is going to give me x e raised to the power 2x over 2 minus e raised to the power 2x over 4 from 2 to 0. Don't forget, I have gotten the area. So this is the moment. Now, I can easily calculate the centroid about the x-axis. So our x can now be said to be equal to 2 e raised to the power 4 over 2 minus e raised to the power 4 over 4 minus, no, this one is 0, minus 1 over 4 divided by, that's the area, half e raised to the power 4 minus 1. So if I should use calculator, this one will become plus, and then from there I will solve everything. So x, after using calculator, I count this. So multiply everything and divide by half here. I got 1.537. Let's quickly see what y will be. So total moment about y-axis is going to be half y squared dx from 0. And what is our y? E raised to the power 2x. And that is going to be e raised to the power 4x dx from. And by the time we solve it, it's going to give us e raised to the power 4x over 4 from 2 to 0. So since that is, so our y, oh sorry, I didn't put half here. So this one is going to be half of this. So our y, so it's going to be equal to, so y will now be equal to half e raised to the power 8x over 4 minus 1 over 4 divided by half e raised to the power 4 minus 1. So by the time we do this, it's going to give us, this one cancel this. So I'm going to have 1 over 4 e raised to the power 8, e raised to the power 8, not 8x please, e raised to the power 8 minus 1 over e raised to the power 4 minus 1. I can still do it further. It's going to give me 1 over 4 e raised to the power 4 plus 1. That's what it will be, because it's difference of two squares. It's going to be difference of two squares, e raised to the power 8 minus 1 will be equal to e raised to the power 4 plus 1 into e raised to the power 4 minus 1. So that's what it is. So that's what it now is solved to. I have 1 over 4 e raised to the power 4 plus 1. So let's solve that. So after solving everything, it gives me 13.90. So which means that the centroid is the point 1.537 and 13.90. That is, the x-axis is 1.537 and the y-axis is 13.90. So I've taken my time to solve this. So whenever you come across anyone, you'll be able to solve it easily. For standard shapes like triangle, squares, circles, semicircles, there are ways we can solve it just by cutting into small pieces like this, finding the moment and then doing your division by the area. So if there is time or if people need it, I can do videos on calculation of the centroid of different shapes. Maybe we can look at one more example before we leave this. So centroid is equal to